Question 90. So it is we are solving the June 2020 mathematical science paper. Question 90 is saying that let X be a non-empty set, and suppose that tau 1 and tau 2 are two topologies over X, and such that tau 2 is a proper subset of tau 1, and which of the following statements imply that tau 1 is equal to tau 2. So this is our findings. So we have this tau 2 is a subset of tau 1, and X of tau 2 is T2, the Hausdorff T2 space. So X of T2 tau of 2 is compact. Now we have for every compact Hausdorff space is normal. So here X of T2, X and tau 2, it is Hausdorff, and compact, so it is also normal, right? So X of tau 2 is normal. This implies that tau is an element of tau 1, which also implies that tau is an element of tau 2, right? That is, tau of 2 is a strict superset of tau of 1. That implies that tau 1 is equal to tau 2, right? So in our case, that if X of tau 1 is compact, right, and tau 2 is T2 space, then we can imply that tau of 1 is equal to tau of 2. So in our case, let's look at the option. X tau of 1 is compact and tau 2 is the T2 space. So tau 1 equal to T2, so option 2 is correct. Okay, tau 2 is T2 space here. Now for any subset, if you want to do this, so let's check with the option number 4, that for any subset A is a strict subset of X, the closure of A in X tau 2 is contained in the closure of A. We have to prove this for tau 1 equal to tau 2. So for any subset, so we can write that A prime by A complement in X of tau 2 is capital X. Okay, is a strict subset of A prime in X tau 1, right? So for any subset, A is a proper subset of X, a strict subset of S, which implies that tau 1 is also a strict subset of tau 2, and we know that from this tau 1 is equal to tau, right? So in our case the option 4 is also correct. But these connected components of both the X and tau 1, that is X tau 1, they are not connected. Okay, they are not the same. So first option is which is the correct option in our case. So first one is for the tau 1 and tau 2. So this is another condition where we can getting. So this is goes for option 2, and here we have the option 4. So these two options are correct only. Option 2 and option 4. Question number 91, the following 2-point boundary value problem. Here the conditions are given that y double prime x plus lambda of yx equal to 0 for x belongs to 0 pi, y of 0 is 0 and y pi equal to 0. Y 0 equal to 0 has y of pi equal to 0 and trivial solution has a trivial solution that y equal to 0. It also has a non-trivial solution for which of the following options we have to find. So now let us directly go to the problem that if we put lambda a value, suppose lambda is equal to 1, and we have already that y0 is equal to 0 and y of pi is given as 0, right? Then the auxiliary equation is m square plus 1 equal to 0, which implies that m is equal to plus minus I. So what will be the equation? Y of x is equal to c1 cos x plus c2 sin x, right? So y of 0, here we will get y of 0 equal to 0, so which implies that c1 is equal to 0, right? And y of x is equal to c2 sin x. Now we will put y of pi equal to 0, which implies that 0 is given by c2 sin pi, which again implies it is 0 equal to 0. So c2 here is arbitrary. You cannot find the value of c2. So if c2 is arbitrary, that is for lambda equal to 1, then the differential equation has non-trivial solution. So we have proved that is the differential equation has a non-trivial solution, right? So option 1 is incorrect. Now if we put that for lambda equal to minus of n square, right? If we put lambda equal to minus of n square, so what y of double prime x minus n square yx is equal to 0, right? So auxiliary equation in our case is m square minus n square equal to 0. So m is nothing but plus minus n. So what will be the solution? So in our case the solution will be y of x is equal to c1 e to the power nx plus c2 e to the power minus of nx, right? So if we put y of 0, then it will be 0 and c1 plus c2 equal to 0 and y of pi equal to 0, which implies that c1 e to the power n pi plus c to the power c2 e to the power minus n pi is equal to 0. So from here we can get that c1 is equal to c2 is nothing but the value is 0. So it has a trivial solution. So option 4 is false, right? Now let's check with for lambda equal to n square. So we will write that y double prime x plus n square yx equal to 0. So what will be the auxiliary equation? The auxiliary equation is m square. So auxiliary equation is m square plus n square equal to 0, right? So which we can say that m equal to plus minus I of in. So now write the general solution. So yx equal to c1 cos x plus c2 sin x. So y0 equal to 0, which implies that c1 is equal to 0, right? And again the y pi equal to 0 means C2 is arbitrary, right? So we have this yx equal to C2 sin x, which has a non-trivial solution. Is a non-trivial solution. So in our case, the option 3 is correct. So we have lambda equal to 1, one of the option, the non-trivial solution. So option 2 is there. And for lambda equal to n square, for all n belongs to the set of natural numbers and n is greater than 1. So these two options are correct option.